Back in January 2021, I bought a Niche Zero. While I love my ROK manual grinder, using it for 5 years across many shots and coffee experiments had physically exhausted me. I wanted an electric grinder and hopefully an upgrade, so I bought a Niche. For some reason, I didn't bother doing a side-by-side comparison at the time, and I stored the ROK grinder until my summer travels. I took the ROK grinder with me to my in-laws, where I had another Chemex machine like my home setup. I immediately noticed I was pulling higher extraction shots with the same coffee that I brought with me. I was planning to leave the ROK grinder there, but I changed my mind so I could do a side-by-side comparison. I broke this comparison up into 4 parts because I wanted to get a deeper understanding on why the grinders perform so differently. Part 1 covers a paired comparison of 19 paired shots using the 2 grinders and the same shot parameters for each pair of shots. Part 2 examines particle distributions to see if there's a better understanding of what's going on. Part 3 goes even deeper using K-means clustering to theorize about performance differences, followed by a short experiment with a sifter to validate the theory. Part 4 examines Burr angle as a possible cause of a difference of performance. So to compare these 2 grinders, I used 2 metrics: final score and coffee extraction. Final score is the average of a scorecard of 7 metrics: sharp, rich, syrup, sweet, sour, bitter, and aftertaste. These scores were subjective, of course, but they were calibrated to my tastes and helped me improve my shots. There is some variation in the scores. My aim was to be consistent for each metric, but sometimes the granularity is difficult. Total dissolved solids, or TDS, is measured using a refractometer, and this number, combined with the output weight of the shot and the input weight of the coffee, is used to determine the percentage of coffee extracted into the cup, also called extraction yield. So first, I needed to dial in the niche. In the beginning, I thought I might need to grind finer, so I spent time dialing in. Typically, I have found setting 13 to be the best, and this was no exception. Setting 13 won in taste and extraction. Setting 14 was a tasty shot, but it was not impressive in terms of extraction. I didn't dial in the ROK. I have gone 1 setting finer than 0, and I've stayed there for the past 3 years. It has been at that setting so long, the part that screws in needs to be replaced. For comparison, I use scatter plots. It is easy to see if the points are all above or below the line. If they are at the line, the 2 have similar performance. I split this data up based on coffee roast, and the results are similar. ROK beats paper. Niche. For general statistics, I have this small table, and I was planning for 30 pairs, but I broke the transfer gears on the ROK before I got to that many. For taste, the results are just shy of statistical significance. More data probably would have showed statistical significance. I looked at dropping 2 outliers, and the p-value dropped below 0.05. In terms of workflow, I prefer the niche because of the electric grinder part. I'm excited that ROK's claims to being a grinder of the same quality as a more expensive electric grinder is true in this case. The study also helps solidify that I want to keep using my ROK grinder, especially for the best roast. As I explore the reasons why, I'm really driving to more deeply understand coffee grinders in general. It seems to me that objective comparisons between grinders are scarce, in part due to the difficulty of comparing them. Let's move on to part 2. I wanted to understand why there was a performance difference, so I collected some grounds, particle distributions, to search for clues. I used image processing to generate particle distribution curves for each of these samples. For all of these roasts, the grinds from the ROK pulled at higher extraction yield than from the niche. This roast had a shift to the right for the ROK compared to the niche, so the ROK was giving a coarser grind. I tried going coarser on the niche, but the extraction yield dropped. This roast had similar distributions, but the ROK was still pulling higher. The story was the same as before, I swept some of the grind parameters for this roast in part 1, and this was still the best setting. There's not a clear answer why the ROK would outperform the niche. Unfortunately, these distributions confused me more than anything. They imply that the particle distributions only tell part of the story. Maybe the particles themselves were different shapes. So in part 3, I wanted to dig deeper, and I turned to pattern recognition. I used linear binary patterns to describe the particles, and then I used K-means clustering to classify them. I looked across different particles and sizes to get an idea of how different particles of similar sizes are to one another. A linear binary pattern is a way to describe a particle by looking at the neighbors in a particle and describing how they relate to each other. And as a result, you end up with a pattern to describe that will describe one particle, and that pattern is size and rotation invariant. So this is very helpful in a lot of image processing and classification problems because an object can come closer into the field of view or rotate, and you would still have a similar way to describe the particle. K-means clustering starts out with a cluster of particles, and you pick the number of nodes you want, and so you assign a couple nodes in this field, and then you find out the particles closest to each node, and then you redefine each node based on that cluster of particles. So every iteration that you go through the algorithm, it redefines these where these mean points are and recollects what particles are closest to them. So this is a way to help separate features in a feature space of particles or whatever you're looking at. So it's a very intuitive algorithm to understand versus something more complex like a neural network, which even people who design neural networks don't really understand how they work inside. Why with K-means clustering, you can understand every step of the way what's going on. I broke down each grind distribution by particle diameter, and then I compared the histograms of how those particles clustered. For some initial data, it seemed the differences were large for particles over 500 microns. So I split up the particles for the two grinders for greater than 500 and less than 500 microns. For less than 500 microns, the particles are very similar and bin into similar clusters. For greater than 500 microns, the niche bins into only 8 clusters while the ROK is spread out, indicating a wider variation of particle shapes. I theorized the ROK grinder produces better grounds above 500 microns than the niche 0. To verify this theory, I sifted coffee from each grinder using a 500 micron screen. Then I remixed the coarser particles of the ROK with the finer particles of the niche and vice versa. By mixing these sifted grinds, I'm able to isolate the coarser particles as a potential problem. I made final distributions for these mixed shots, and the distributions are very similar. Using the ROK coarse grounds with the niche fine grinds results in a similar shot in taste and extraction as the ROK grounds on their own. Doing the opposite resulted in a worse tasting shot than the niche grounds alone, but the output to input ratio for the one shot was slightly higher at 1.5 to 1, and the other shots were at 1.3 to 1. This investigation was interesting to me because I have not found a good way to compare grinders. Typically, people use distribution curves, but when they match, how can you quantify the difference? Very interested in applying this technique to help distinguish higher-end grinders. By swapping the grounds, it is clear that the difference in performance comes from the difference in coarse grounds that the two grinders make. The story wasn't over. Part 4 happened a month later. A replacement Burr showed up for the ROK, and I thought I had captured all the variables, but there was one I was missing. The niche burrs sit at an angle of 15 degrees, while the burrs for the ROK are at 0 degrees relative to the countertop. Could this be another angle to look at? I did a quick comparison by angling the niche to 0 and angling the ROK to 20. The most stable platform I had was a computer stand because hand grinding causes the grinder to move around a lot. I compared using grind distributions in a few sample shots and then a couple paired shots. In looking at the grind distributions, I was surprised the niche matched the ROK at an angle and vice versa. The burrs at an angle would cause a difference in grind distribution, but I didn't consider how much that would be. We can look how similar the particles' shapes are using linear binary pattern and K-means clustering. The niche at an angle compared to the ROK as it normally would be are more similar than the ROK as it normally would be versus the niche angled. Splitting it up by particle size, the niche has a big difference, normal versus angled, while the ROK angled is more similar to the niche normal for greater than 500 microns. This means the coarser particles are more similar in shape, and this was the main difference found previously to be the root cause of the ROK beating the niche. I did 2 shots for each grinder with and without an angle. When the grinders have the same angle, they have similar taste scores, as well as extraction yields. The niche at 15 degrees had a higher TDS but a lower EA because it was a little shorter shot than the others. I took 9 paired shots where I set the niche at an angle 0. Each graph compares the burr at angle, how the niche is normally set up, and the burrs level to the table, which is the niche pushed back by 15 degrees. This data didn't show a trending difference between the 2 angles, so it was inconclusive. I would have expected the burrs parallel to the table to have higher extraction yield and a better taste, but they are pretty similar. I really enjoy both grinders, and I hadn't considered grind angle as a possible variable that would affect a grind distribution. It seems that with respect to the burr sets in both grinders, they seem to be only different at angle offset. This data does exist somewhere in the research for grinders for burr angle versus performance, and hopefully one day this data would be made available to the common folk to better understand grinding as a process.